Hey everybody, make sure you have these notes in front of you and a calculator. You definitely need a calculator on this. This is our last topic before we practice for the unit test. Make sure you put your name at the top. Today we're talking about percent change. And it's really not much different than even percent error. We do it in a very similar way. We just want to know how much something has changed. Sometimes it's an increase, sometimes it's a decrease. Don't forget, increase means it's going up, decrease means it's going down. Okay, percent of change tells us the amount it's increased or decreased in relation to the original amount. I can't stress that enough. It's always compared to the original amount. So there are two ways you can do it. You can use our percent equation like we have been. Percent times the original equals new, and then subtract at the end. Or you can subtract in the beginning. By the way, this shouldn't be an equal sign, it should be a subtraction sign. Oh my gosh, it shouldn't even be that. It should be a division sign. Oh, for goodness sakes. Sorry, typo. So we could also find the change in value and divide that by the original. Find the absolute value, multiply that by 100, and that equals the percent change. It's not as hard as it sounds. Just don't forget, you're either subtracting in the beginning or at the end, but you will always be subtracting somewhere. Let's move on down and try some problems. This was a question on the New York State test last year. It says the Lions won 16 games last year. Okay. This year, the Lions won 20 games. Well, first, I should probably identify what the original is, and this is the original. 20 games is the new. So sorry I was interrupted. Okay, so where was I? This is last year, so that's the original. And this is the new. So we are looking for the percent. That's the percent increase, okay? So let's do it the way, my favorite way to do it is kind of like we've been doing percent error. I want to find the difference first, so I'm going to do 20 minus 16. It's always in relation to the original, which in this case is 16. When I multiply that by 100, that will give me the percent. Okay. So 20 minus 16 is 4. All right, we're doing well so far. 4/16, if you could put that on your calculator, I think you're going to decide it's the same as 1/4 or 0.25. And if I do 0.25 times 100, that gives me 25%. And that answer is right over here. So it was an increase. I'm going to just draw an up arrow so you know that that was an increase of 25%. Now there's another way to do it. I'm not telling you this to confuse you, just teaching you another way so it makes sense. The other formula they gave us was new equals percent times the original. In this case, nothing has changed. The new is the 20, right? This year, yeah, that's the 20. The percent we don't know, and we know the original is 16. If I divide both sides by 16, let me make that go all the way across. And if you put 20 divided by 16 on your calculator, I'm pretty sure you get 1.25. Now this is the problem. This really means 125%. But did it really increase 125%? No. This is from 100%. So it really increased 25%. I just don't like it as well that way. I just like to do the one step and be done. So I'm going to move on. As we scroll down, this is another New York State test question. It says the store sold 650 bicycles last year. This year, the store sold 572. Okay, think for a minute. The original means what was it to begin with, and that's this part. So I'm going to write original here. This part is the new price. I want to know what the percent decrease is. Now keep in mind, we know it's a decrease because we didn't sell as many bikes as we did last year. So I'm going to do my 650 minus 572 because just like percent error, I want to know what the difference was. So go ahead and use your calculators and subtract that. I get 650 minus 572 equals 78. And don't forget, this is always in relation to the original. So I need to divide this by 650. Okay, now 78 divided by 650. When I multiply that by 100, I should get, you try it on your calculators. My decimal I get is 12 hundredths times 100 is 12%. That's a 12% decrease. I'm going to just draw my down arrow so that you know it was a decrease. And I'm moving onward. Now let's see if I can scroll down here. There's another problem. Lee bought a used car for X dollars, so we don't know how much it was. 1 year later, the value of the car was 88 hundredths X. Which expression is another way to describe the change in the value of the car? Well, if we bought the used car last year, the original amount would be 100%, or written as a decimal, 1.0. Now it's 0.88. So if I subtract those two, I just put a zero placeholder here. Go ahead and subtract with your calculator. You should have found that it is a 0.12. Well, what does that mean? Is it a 12%? Yes, because we have to multiply that by 100. It's a 12% decrease. I'm hoping you're not thinking these are too hard, since we just did percent error, and they're very similar. I want you to think about this too. All of the things we've been working on are really all related. So discounts are really related to percent decrease problems. It says Suzanne bought a sweater at the sale price of $25. Awesome. The original cost of the sweater was $40. Ooh, we better mark that. So this is the new price, right? What percent represents the discount that Suzanne received when buying the sweater? Well, let's start with this. This case, I really want to use this formula. The new equals the percent times the original. The reason I want to is because it might be a little harder to subtract. So the original price of the sweater was $40. The sale price was $25. If I divide 40 on each side, cancels that out. 25 divided by 40 equals 0.625, which means it's really 62.5%. Does it make sense? Let's go back. Suzanne bought a sweater at the sale price of $25. The original cost of the sweater was $40. Wait a minute. This makes it sound like we took off more than 50%. It's 62% off? No, this doesn't even make any sense. So what did we do wrong? Let's try it the way I like to do it. Okay, let's find the difference or the change over the original. Times 100. I'm promising not to try to keep confusing you. I do want to show you that sometimes we get wrong errors or wrong answers, and you need to know that it doesn't make any sense. So the difference between 40 and 25 should be compared to the original price, which was 40. 40 minus 25 is 15. 15 divided by 40, let's check it out. 15 divided by 40 equals 0.375, which is really 37.5%. That one makes much more sense. We're going to circle that and move on. This is why I like to use this formula better. Also can be related to a markup. The population of a city is expected to increase by 7.5% next year. If P represents the current population, which expression represents the expected population next year? If I have a P, just think for a second, how many P's is that? Yeah, that's 1. 1 is the same thing as 100%. So if I add 100% and 7.5%, wouldn't I get 107.5%? That seems like if I got rid of the percent sign, I should get 1.075. If you don't believe me, type this into your calculator with a percent sign and press equals. So if this is what my new population is, I include my P, because it's really 1P plus 0.075P, and that equals 1.075P. That's it. Is it here? Sure is. There's our answer. The rest of the problems should be practice for you, and we'll go over them if we need to.